Hello, welcome to my tech farm. My name is Igor and currently I'm on my workplace where I have this Ender3 V2, which is approximately 3 months old 3D printer. And at home I have one of the early birth Ender3 V2s, which I got from the Mainboard for a review maybe 2 years ago. And I noticed this one is a little bit different, but still needs some safety upgrades. Some of them I noticed during that my previous video when I measured the temperature inside and outside of the enclosure. And some of them will be done around the mainboard. For example, I want to crimp some ferrules on high current wires. Also, I want to do a rewiring of the mainboard fan because I noticed it is rotating only when the part cooling fan is on. Also, I want to add some ventilation holes on the power supply unit. And a few other things. I want to check is it the thermal runaway protection enabled, because our early printers didn't have this. I hope this one has. If not, in that case I will update the firmware too. At home I'm using now the Gyros firmware, which has enabled the thermal runaway protection, so I will see here if this is necessary. And also I want to change the springs here because it's not so big safety issues. Safety from that aspect that I don't have to re-level the bed so often, and there is a bigger chance to my printing to be successful. Don't forget you have the timestamps down in the description, so you can jump to any part of the video. Here you can see the list of the upgrades I will do in this video on this printer. So let's start with disassembling the mainboard cover. From the safety reasons, start with unplugging the power cable. There is one screw from the top. I always like to move the Z-axis higher so it will be easier to work with it. And put some kind of support below it, so don't put it on the stepper motor holder. Don't forget this one is longer, so this will go back here. And there is our fan and the connection. So here we have these terminals with high current wires. On the left side we have the plus and minus, which goes to the heating cartridge of the nozzle and hot end, and then these wires, these are wires for the hotbed. And on the right side we have these two wires which goes to the hot and cooling fan. These are not high current wires, but they are important for us because here I want to rewire this mainboard cooling fan. And same has to be done with this wire, which is the input power for the mainboard. Interesting, the wires which goes to the hotbed are the same color, so I will just in case I will mark with the black the minus. So here they are. I pulled them out from these terminals, and now you can see the problem. So they are only tinned, there are no ferrules on them. Now I'm only a mechanical engineer, I don't want to go into discussions why are ferrules better than the tin wires. I'm talking about high current wires. Something like that, the thin wire are more sensitive to this thermal dilatation when the high current goes through them. And by time they became loose in these terminals, and if they lost the good contact, there's potentially danger for the fire or smoke or something like that. So I'm not sure how big is the difference, but I know the ferrules are a much safer solution. I will start with the heating cartridge wires, so I will just cut the thin part. And I clean approximately 5 mm from the end of the wire. These are the tools I will need for crimping, and I have some terminal assortment here. Different color are for different size of the wire, but basically I will search for one which best fits on this wire diameter. Looks like this diameter will be good for this wire, and this part goes completely to the end of the insulation. And then I can crimp the end of this wire. And just try to pull it out a little bit, but it should be secured now. And same with these hotbed wires. Now after this cutting they may be a little bit short, so I just pulled a little bit more this cable in this cable holder. Cleaning the end of the insulation a little bit more. Well, as you can see, these are much wider wires with bigger cross-section area because the hotbed needs much more current. And this is how they look like after the crimping, the ferrules, and now I have to place them back, but only these 4 wires, and later I will play with the hot end fan. It's a little bit hard to work on the small space and to be everything on the camera, but I hope it is visible now. It's in this terminal, and always check a little bit with your finger, can you pull it out, is it secured, just in case, but it should be okay. And same has to be done with this wire, which is the input power for the main board. And it's done, and don't forget the polarity is very important. Black is minus and the red is plus. Now let's talk about this mainboard cooling fan. Let me unplug it. So it's connected with this JSB connector to the mainboard. Now the problem with this fan is that it is connected parallelly with the part cooling fan. This means if the part cooling fan is off, this will not rotate. This is not the problem with printing PLA, because there the part cooling fan is always on 100%, except after the first few layers. But if you're printing PETG, you want to reduce the part cooling fan, or with ABS, ASA, you want sometimes completely disable it. And imagine inside the enclosure, completely disabled mainboard cooling fan during the whole printing, so these stepper motor drivers don't get any cooling air from this fan. Now the solution is basically to connect this to this terminal. When I unplug these 2 wires, these are wires to the hot end cooling fan, which is always on, and that's what I want here with this fan, which is the mainboard cooling fan. Only don't put 2 wires into one terminal, because you will never know when will the screw be supported by only 1 wire or 2 wires, and in that case the second may be loose, and of course this is a very small current, it is not too big problem, but it would be good if this is stable. As you can see, I chose the laziest solution. So these are ferrules, this will be screwed into the mainboard, and I will solder here those 2 fans. So if I want to replace the fan, then basically I have to unsolder it. I prepared some shrink tube and I will insert it now, because if I solder this, then it's too late, I cannot place it on it. But you can use any insulation tape if you want to. With the fans, the polarity is important, otherwise it will spin to the opposite direction. And now I can screw in these wires to terminal. Looks okay, just a quick test, and then I can move to the next step. And it's already rotating. And also the hot end cooling fan is rotating. And just quick test of the nozzle heating and the bed. And I can feel that the hot end is heating, and also the bed, so everything works, and now I can move to the next upgrade. Before I place back the mainboard box cover, first I wanted to check the thermal runaway protection. It is the protection in firmware which, if there is some error, it cuts off the power of the heating. Let's say you set the nozzle temperature to 200 degrees Celsius, but the thermistor fall out, or maybe the thermistor wire broke or something like that, so it is pumping the current to the heating cartridge, but the temperature doesn't raise. In this case, this protection should recognize this, that something is wrong, and it should give us a warning and cut off the power from the heating. Otherwise, it should constantly pump the heating, but the temperature is actually not changing because it is constantly reading the room temperature if the thermistor fall out, and that may result some smoking or maybe even some fire. And I turn on the printer and I will set the temperature of the nozzle to, let's say, 200 degrees Celsius. And as you can see, the temperature doesn't change because the heating wires I take out, and in a few seconds it should recognize that the temperature is not changing, and it should give us an error and cut the power of the heating. And approximately after half minutes we get this nozzle is too low temperature. So good news is that now the Ender3 V2 arrives with thermal runaway protection enabled. I know that some very early versions didn't have this option, or maybe the Ender3, the original. Well, definitely in that case I would suggest the firmware update. It's with Ender3 V2, since it has the bootloader installed, it is very simple. You just have to download the bin file, the firmware, to the SD card, place it into this slot, and after you turn it on, it will update the firmware. Sometimes you have to do it separately for the screen too, but it is very simple, so it's not complicated. Now I can place this mainboard box cover back. Oh, first I have to install these wires. Let's remove the power cable for the next step. And the next safety upgrade will be the ventilation holes on the power supply unit. Now Ender3 and Ender3 Pro, the power supply unit was here on the right side, which was I think better solution because it is very accessible, but now probably from the aesthetics it moved down. So to access it I have to turn again the printer. So this is the mainboard box and this is the power supply unit. And as you can see, there is some ventilation hole, there is a fan inside. It is quite covered, but okay, I can see these holes. But the problem is, you will see soon that here the power supply unit has designed some ventilation holes. So the fan here sucks the air, and probably here it should go out. But these are covered by this black plate. Now to remove this, unfortunately, I have to remove these two screws here from the side. But to access to them, I have to take out the power supply unit from its place. So I have to start by removing these 4 screws from the top. And from the bottom I have to remove this screw. These wires are in the way, so I will remove this zip tie. And now I can access to these 2 screws. And this is what I was talking about. So we have these ventilation holes, and I'm sure that if they are here, because this power supply is not designed by Creality, so they designed this with a reason. So probably the fan is sucking the air here, and it has to go out here. But as you can see, they are covered, so I just create some ventilation holes on this plate here. Don't forget that the power supply cable should be pulled out before this stage. So center line of the ventilation holes will be in this plate, but they has to be here. And this middle line I marked here. And this is 10 millimeters from this hole. So 10 millimeters from this hole will be the center for this ventilation hose. And from this plate, approximately 32 and 82 millimeters will be the center for this ventilation hose. For this drilling into plate, I will use the step drill. Be careful if you are using the twist drill, because if you are drilling into thin plate, when you drill it, it may pick up the plate because of this spiral channel, and it may rotate together with the twist drill, so be careful if you're using this type of the tool. So I deboard the edge from the other side, and I will clean it a little bit from chips, and it's ready. So not a big holes, but definitely better than nothing. So I think this will reduce the enabling of the fan because the temperature will be lowered inside. So it will be like this. As you can see, not a perfect solution. There are a lot of better solutions from this, but for me this was the simplest. I screw in one bolt before I turn it on, so it's holding it in position. And it's finished. And my next upgrade will be replacing these springs. These are much stronger springs. Theoretically, this is not really for the safety reason. Well, it could be for the safety of the 3D printing, because these springs holds the position of the bed better, and I don't have to re-level the bed so often. First I have to unscrew these knobs. Don't forget, move the Z-axis higher so you have more space for the work. And be careful because the cable is attached to the end of this bed. So these are those original springs, and these are those new, stronger yellow version. And I will try to press it with the same force. And I hope it's visible. So definitely much stronger are these yellow springs, and they will hold the position much longer. Now pay attention that on the back left side we have this cable holder, so the spring will go below it. Let's find the holes. Okay. So definitely a highly recommended upgrade because it is very simple and cheap, and don't forget you have to re-level the bed again, and after this you don't have to do it so often. And there is one more safety upgrade I want to do on this Ender3 V2, and that's installing the flexible sheet. Why? Well, this printer will mostly be used by my students, and I can see that young people are not too careful. And most common injuries in 3D printing is made by this, the spatula. What is the English expression for this? I'm not even sure. When you print on the glass, and sometimes if you print bigger object, it sticks to it very good. And trying to remove it, and suddenly it runs and cut your finger or something like that. So I can see so often that even on a Facebook. So definitely a safety upgrade will be using this flexible sheet. In this case it's magnetic. You can remove the flexible PEI sheet and just start with the flexing, and you can very easily remove the print object. This is Creality's PEI sheet with magnetic base, and it can be stick to the aluminum plate using this 3M sticker. I already did a review of this PEI flexible sheet. I will place a link down in the description. I moved the Z-axis higher, and I'm starting with the cleaning of the aluminum plate with some isopropyl alcohol. I'm starting with removing the 3M sticker, maybe 3 or 4 centimeters from the magnetic base, and it is very easy to start parallel with this edge. And then use some flat but not sharp object to press all the air below the sticker. You can use the credit card or something like that. And magnetic base is installed. This is the steel plate, flexible steel plate with the PEI layer on it. Unfortunately only one-sided, but never mind, at least the contact between magnetic and the steel is better. And we are ready. For those who still wants to use the glass from time to time, you can do it by placing the glass on the magnetic base. Only you cannot use those stock clips anymore, but something like this. I already measured it, so the heating time is a little bit longer, maybe 20 seconds more, because we have additional layer of the magnetic base, and set the temperature maybe to 3 or 4 degrees higher, but in that case you can use the glass as it was before. And don't forget, after this installation you have to re-level the bed again, except if you have the BR touch. And also don't forget, before every printing, use some isopropyl alcohol to clean the PEI surface. So these were those safety upgrades which I did on this Ender3 V2. Doesn't mean they are all mandatory. For example, if you print only PLA, in that case you don't have to rewire the mainboard cooling fan, because in PLA printing the part cooling fan is always on maximum, and this means that mainboard cooling fan will be always on 100%. About power supply unit, they all work. I mean, thousands of this Ender3 V2 is sold and they all work, but I think the lifespan will be longer with this power supply unit. Now it's a little bit late, but now I got in my mind that I could measure something. For example, how often will the fan turns on before this upgrade and after this upgrade. So maybe if somebody wants to do this upgrade, he could measure first how often the fan on the power supply unit turns on, and after this upgrade, and I think there will be significant difference. If I skip something, maybe you know some important safety upgrade too, then please write me a line down in the comment section. Thank you for watching, and happy and safe printing. Bye.